discuss question 2 here from the same module, project Ticket to Victory Chemistry module. Okay, chapter 2, question 2. Okay, okay, question 2 is about isotope. Okay, let us read the question. Number 2A. One of the elements in acetamide is carbon. Okay, carbon exists in a few isotopes. Two of the isotopes are given. Okay, it's actually they have given carbon 12 and carbon 14 there. Okay, first of all, when they give you a standard representation, we should be able to identify what is the upper subscript and lower subscript number represents. Okay, so the upper subscript actually shows reflects the nucleon number. Okay, nucleon number. Then the lower subscript actually represents the proton number. Okay, proton number. Okay, so they have given you carbon 14 and carbon 12 actually. Okay, let's look at the first question. Okay, first question they are asking what is meant by isotopes. Okay, when they ask what is meant by isotope referring to definition, they want definition. Okay, so in the question itself they have already given you the key points for your definition. It means they have already stated there, but we just have to make it in the form of a sentence. Okay, let us compare the isotopes first. Okay, so isotopes, you can see they are actually from the same element, so that is the first key point. Okay, referring to the same element. Okay, second key point, you can see that the proton number is the same. Okay, so they have the same proton number. Okay, and the third key point will be the nucleon number. Okay, so the nucleon number is different. So it has different nucleon number. So by using the three key points, we can actually define the definition here. We can define the definition. Okay, only thing is that we have to state actually it exists in the form of an atomic state. So we are talking about atoms actually. Okay, so when they ask us to define, we have to start with the key point atoms. Okay, compulsory for us to start off with atoms in order to get the 1 mark. Okay, so let us define. Okay, the definition for isotope will be atoms of the same element. Okay, first key point, of the same element. Okay, with same number of proton, with same number of proton or same proton number, you can retain the key point. Okay, same proton number, but different nucleon number. Different nucleon number. Okay, so all the required key points are there. Atoms, okay, of the same element with same proton number but different nucleon number. Okay, so with this we can get the 1 mark given. Okay, so here common mistake made by candidates. Okay, common mistake by students. Okay, they tend to use a wrong term, meaning they use the word neutron number. Okay, they make a sentence like atoms of the same element, either they use same proton number, okay, or same number of proton, is okay, correct. But when it comes to nucleon number, but different neutron number, okay, which is wrong, because this neutron number term is actually does not exist. Okay, they have come up with a new term. So that will be the common mistake by the students. Okay. So let us look at the question number 2. Okay, state one usage of carbon 14. Okay, so very simple. Okay, to estimate, okay, or to determine the age of fossils. fossils, or you can also write ancient artifacts. Accepted, ancient artifacts. Okay, ancient artifacts. Other acceptable answers, maybe you can write there. Okay, yeah, for carbon dating is also correct. Okay, yeah, for carbon dating is also correct. Okay, yeah, but make sure the spelling for fossils, artifacts are all correct. Okay, yeah. So you get one more mark there. Okay, so let us move on to the next question. Okay, what is represented by the number 12? Okay, I've already stated up there. 12 is actually representing nucleon number. Okay, yeah, they're not asking for the meaning. They are asking for the term that represents 12, which is nucleon number. Okay, yeah, so the answer is nucleon number. Again, please check the spelling. Okay, in order to get the 1 mark. Okay. Let us move on to the next question. Okay, they are asking us to write the arrangement of electron for the atom. Okay, yeah. So arrangement of electron meaning we need to get the number of electrons. Okay, yeah. For atom, we must understand if it's an atomic structure. Okay, for atoms. Okay, yeah. The number of proton is the same as the number of electron. Okay, number of proton is same as number of electron, which is 6 in this case, because this is the proton number. So if proton number says 6, that means the total number of electrons also should be the same, which is 6. Okay, so based on that, the arrangement of electron, we all know that the first shell, maximum electrons you can put in will be 2. Okay, so you put in 2 dot. Okay, then the balanced electron will go into the second shell. Okay, yeah, 2 or 4. Okay, yeah. Please try to stick to the same format. Okay, yeah. Try not to use comma or double dot to write the arrangement of electron. Okay, yeah, 2, 4. Okay, why is carbon used as a standard element to determine the relative atomic mass of an element? Okay, yeah. That is because carbon exists in the form of solid. Okay, because carbon is solid. Okay, carbon is solid. Since it exists in the form of solid, so hence it can be handled easily. So acceptable answer, either you write there carbon is solid, or you can also write there easy to handle. Okay, easy to handle is also accepted. Okay, carbon is abundance. Carbon is abundance is not accepted. Okay, so this will be the common answer. Either you write there carbon exists in the form of solid, or because it is easy to handle. Okay, okay, next question is something new. It's a part of your new syllabus. Okay, they are asking us to calculate the relative atomic mass for different isotopes. Okay, so here they have given you for magnesium 24, magnesium 25 and magnesium 26. Okay, so let me write it down here. If magnesium 24, the percentage will be 79%. Okay, magnesium 25 is 10%. Okay, and magnesium 26 is 11%. Okay, so the relative atomic mass you have to total up all. Okay, based on the percentage. Okay, so 79, the percentage multiplied with the relative atomic mass. Okay, so 79% multiplied with 24, the relative atomic mass for magnesium 24, plus 10% multiplied with 25, plus here 11%. Okay, 11% multiplied with 26. Okay, so the total you have to divide with 100. So the answer will be 24.32. Okay, so if the question asks you to state the relative atomic mass, okay, state relative atomic mass. So as for relative atomic mass, there's no unit. But if they ask for molar mass, Then compulsory for you all to state the unit, which is gram per mole. Clear? Method of answering for, say for example, relative atomic mass for magnesium oxide. For magnesium, which is 24. Okay, yeah? Molar mass will be 24 gram per mole. You have to state the unit. So be alert with the question. If they ask for molar mass, state the unit, gram per mole. If they ask for relative atomic mass or relative molecular mass, RMM. Okay, yeah? Then no unit. Okay, yeah? You don't have to write the unit. Okay, let us move on. Okay, that's it for question 2. So we have done question 1 and question 2 in the tutorial session. Okay, next tutorial session will be on essay. Thank you.